absence of turbo lag, which was present in the turbo coupe. But the truth in performance could only be proven on the track, and the Super Coupe was one of the most popular vehicles to drive. Comments about the overall performance were positive, and those individuals who really pushed the Super Coupe were amazed at the bottom-end performance, thanks to the supercharged engine's great low-end torque. The addition of the supercharger meant several changes to the 3.8-liter engine, over and above those that we just mentioned for the base engine. These changes and improvements include the following: a distributorless ignition system, or DIS. This advanced ignition system eliminates the need for the distributor cap and rotor. It uses a crankshaft position sensor to time the spark plug firing along with a camshaft position sensor. The camshaft position sensor is in the position where the distributor used to be and synchronizes the spark plug firing by indicating when the number 1 cylinder is coming up. The spark originates from a new triple-pack coil. The whole system is regulated by the EEC4 system. A knock sensor has been added to detect detonation. The sensor allows the EEC4 system to alter spark advance to prevent detonation from occurring. In the combustion chamber, the air-fuel mixture is being fired by new platinum-tip spark plugs. These spark plugs provide extra long service life and have a 60,000-mile service interval. Both the cylinder block and cylinder head have been strengthened to contain the increased pressure generated by the supercharger. Another component that has been strengthened substantially is the crankshaft. It is a Duracast ductile iron design, rather than the conventional nodular cast iron alloy. The addition of the supercharger and its related hardware resulted in a completely redesigned intake manifold. There are no individual runners in the intake manifold. Rather, it is an open-area plenum. This is possible because the pressurization of the air charge by the supercharger allows for uniform air inlet to each cylinder whenever the intake valve opens. A special high-lift, long-duration camshaft is being utilized in the manual transmission version of the Super Coupe. The automatic transmission version of the Super Coupe has the same camshaft as the base 3.8-liter engine. An aluminum oil pan is utilized on both the base and supercharged engines. The oil pan is die-cast and bolts to the transmission bell housing to provide added powertrain stiffening and improved NVH characteristics. Another feature is the air-to-air intercooler, similar to the one used on the 1988 Turbo Coupe. Its purpose is to cool the air entering the engine for a denser, more oxygen-rich air charge. The cooling system has also been redesigned for the supercharged engine. It utilizes a downflow radiator and an 8-blade electric cooling fan. The base engine uses a conventional belt-driven fan with 7 blades and a cross-flow radiator. The major component and the reason for all these improvements is the supercharger. It's a Roots-type supercharger, mechanically driven by the engine rather than by exhaust gases, as is a turbocharger. The counter-rotating rotors trap air within the supercharger body, compressing it and forcing it under pressure into the intake manifold and into the combustion chambers. The increased density of the air-fuel mixture in the combustion chambers increases engine power. Because the supercharger is mechanically driven, it requires horsepower. In fact, at 5,000 RPM under full boost, the supercharger can draw up to 60 horsepower. However, the overall increase in engine power under full boost more than compensates for this power draw. A point to note is that most of the power draw occurs only in high-demand situations requiring boost. While cruising at a steady 55 miles per hour, for instance, the supercharger draws only about 1/2 horsepower. The supercharger is driven at a continuous speed 2.6 times that of the engine. It generates a maximum boost pressure of about 12 psi at 4,000 RPM under a full load. The keys to the operation of the supercharger are the rotors. Note that they are helically designed rather than straight. The helical design allows a smooth flow of pressurized air into the engine and also cuts down on the gear whine that is often associated with superchargers. In fact, the noise levels, especially under boost, are significantly lower than on the previous Thunderbird Turbo Coupe. Now, let's take a look at how the supercharger system functions. To begin, air enters the system through the remote-mounted air cleaner and passes into the mass airflow meter. It travels through the throttle body assembly and continues through the supercharger inlet plenum assembly into the back of the supercharger. The air is pressurized by the spinning rotors and exits through the top of the supercharger by way of the air outlet adapter. The compression of air causes its temperature to rise. So, from the supercharger, air is conducted to the intercooler, where ambient air passing through the intercooler removes some of the heat generated by the supercharger. Intercooler operation is quite efficient in that the air exiting the intercooler can be up to 150 degrees Fahrenheit cooler than incoming air. From the intercooler, air is routed by piping to the intake adapter that is bolted to the rear of the intake manifold. From this point, air moves into the intake manifold plenum area and then to the combustion chambers. When the intake valve opens, air is forced into the combustion chambers, where it is mixed with fuel delivered by the port-mounted fuel injectors. A special point to note is that the system incorporates a bypass which branches off from the upper portion of the intake manifold adapter assembly. The bypass incorporates a simple vacuum motor that regulates the amount of air to be bypassed according to the power demands placed upon the engine. As the engine's power demands increase, the vacuum motor modulates a butterfly valve to progressively close off the bypass and route more of the air to the intake manifold, thereby increasing boost. Maintenance on the supercharger is limited to the following checks and component replacements. The supercharger has its own dedicated sump. Oil should be checked at the 30,000-mile major service intervals. Periodic oil changes are not required on the supercharger. If oil is required, use the special oil recommended in the shop manual. Operation of the bypass valve should be verified in the event of a performance complaint. Serviceable components on the supercharger assembly include the vacuum actuator assembly, inlet tube and valve assembly, supercharger outlet, and the base supercharger and outlet assembly. That completes the look at the 3.8-liter supercharged engine. A new manual transmission is being used in conjunction with the 3.8-liter supercharged engine. It's the M5R2. Service procedures do not differ drastically between this transmission and other manuals. However, there are several important design points that should be noted. The shifter is placed further back on the transmission, and also a longer tail shaft is utilized. Well, that completes our coverage of the suspension and driveline features of the Thunderbird. But there are many other features, primarily in the electrical and electronic area. These features include the utilization of the Integrated Vehicle Speed Control System that is controlled by the EEC4 system, new instrument clusters, a diagnostic maintenance monitor, and the addition of the JBL2 audio system and digital audio disc player as optional equipment. Let's take a closer look at some of these features, starting with the instrument clusters. The Thunderbird base instrument cluster consists of an electric-driven analog speedometer with trip meter and magnetic fuel and temperature gauges, along with a full host of warning and indicator lamps. The Thunderbird LX is equipped with an electronic instrument cluster as standard equipment. The electronic instrument cluster is made up of 10 lamps and is sensor information and controls the gauge display, the speedometer, odometer, and tachometer displays, and the fuel computer. In addition, there is a remote module that consists of 4 switches that control the operation of the electronic instrument cluster, such as the English metric readout, speed alarm activation, and selection of the fuel computer features. The Super Coupe is equipped with an analog cluster as standard equipment. It is composed of an electric-driven analog speedometer with trip meter and 120 miles per hour, 200 kilometers per hour display, electric-driven analog tachometer, magnetic oil, fuel, and temperature gauges, and a mechanically operated vacuum boost gauge. In addition to these gauges, there is a full complement of warning lights and indicators. In addition to the new instrument clusters, a vehicle maintenance monitor is being utilized. The vehicle maintenance monitor monitors oil change intervals along with 4 fluid levels. They are engine oil, radiator coolant, fuel, and windshield washer fluid. Note that after an oil change, the VMM must be manually reset. Another important point is that the VMM is equipped with self-diagnostics to locate malfunctions. The JBL2 radio and digital audio disc options are both new to the Thunderbird for 1989. With the JBL radio option, there are additional speakers added into the system. They are referred to as satellite speakers and are a new design. The most important speaker to be aware of is the subwoofer, in addition to the existing speakers beneath the package tray. The subwoofer is used to increase the bass output. Note that there is an amplifier used with the subwoofer. If for some reason the subwoofer is disconnected at the amplifier, the radio will not work. If an inoperable JBL radio malfunction arises, make the subwoofer connection one of your first checks. To complement the JBL radio, the digital audio disc option is also available. The disc player can only be ordered in conjunction with the JBL system. It cannot be ordered with other radios. Another major change on the Thunderbird is in the climate control system. The system is a manual type and features a new push-button control head. Another component that's new is the FX15 air conditioning compressor. Well, that completes our look at the features of the 1989 Thunderbird. But there's still more exciting news to see, and it's with the 1989 Taurus SHO, Ford's answer to the high-performance sedan market.